this video clip, we will talk about set operations. The first one is about intersection. If a set consists of all elements which are in both sets of A and B, then the set is called the intersection of sets A and B, and it is denoted by A. This sign is like a cap. So A intersection B. Here is the example. You see we have a set A which consists of 5 elements. 1, 2, 3, 4, 5. The diagram for A is right here. And then we click A here. This diagram will disappear. You then click B. B has 4 elements. 4, 5, 6, 7. Okay. And then, what's the intersection? Intersection is the common parts of A and B. 4, 5 in A, 4, 5 is also in B. So then intersection, the common part of A and B will be 4, 5. You see, we click A, it shows up. So 4, 5, this common part, if you click on A intersection B, that will be the intersection of AB. So basically we say this overlapped part of AB, or this area shaded twice, will be the common part of AB. Okay, so you click A disappeared. You click B disappeared. So this part will be the intersection. All right. Okay, let's see another example. Here we have a set A, which is a set of parallelogram, and B is the rhombus, and C is a set of rectangle. So we want to find out the intersection of A and B and the intersection of B and C. First of all, we need to understand what's the meaning for the parallelogram, rhombus, and rectangle. If you forget the definition, you may click on this blue parallelogram. You see a screen will pop up. You may adjust the size, the size right here. You see, what's the meaning for parallelogram? That's like this. 2 opposite sides are parallel. Okay, you see this side and this side are parallel. So this side and this side are parallel. How is rhombus defined? The rhombus is defined based on the parallelogram. So you see here, if 2 adjacent sides are equal in a parallelogram, so that tells us that if these 2 sides are equal, then the parallelogram will be called a rhombus. Okay, that means that a rhombus has to be a parallelogram first. Okay, with that in our mind, we can then do this question here. A is a parallelogram. So B is a rhombus. Then we know again, rhombus has to be a parallelogram first. So every element in B has to be in A. Then the intersection between A and B will be actually what? The set B. Okay, so that's the reason. That's the reason. Okay, so you see B is contained in A. Okay, so it's like B is a big circle. A is a big circle, and then B is contained in A. So the common part of AB, of course, is the smaller part, B. We have seen this before. Okay, you got to review that. So here we have A intersection B will be B because B is the subset of A. So we see this example before. If one set B is a subset of A, so then this B graph will sit inside the graph of A. So then, of course, the common part will be the smaller one. So A intersection B is B. Please review the previous one. All right. Now, how about B intersection C? B is a rhombus. It means that actually four sides of the parallelogram are equal. Okay, that's the definition or the property of a rhombus. And C is a rectangle. Rectangle requires what? Requires every angle is 90 degrees. You see right here. Let me move this a little bit higher. This is rhombus. So parallel and four sides are equal. If we required one angle is 90 degrees, that basically it says what? One angle is 90 degrees, the rest of the three has to be all right angles. Okay, all 90 degrees. So in this way, if we require that rhombus is a figure is both a rhombus, that means four sides equal, and at the same time, it has to be a rectangle, means four angles are equal. Then it has to be a square. Okay, so that's why we have the answer right here is that B intersection C, rhombus and concurrently is a rectangle, then it has to be a square. Okay, so that's the example for 1.16 for this example. Now keep going. We have another example here is that Professor Smith's office hour is on Mondays, Wednesdays, and Fridays. So basically set A has three elements. Mondays, Wednesdays, and Fridays. Okay. And Professor Winning's office hour is Monday, Tuesday, Wednesday. So this is Professor Winning's office hour. Mondays, Tuesdays, and Wednesdays. What's the intersection of A and B? That's the common part. Common part here, they are Mondays, so Mondays. And then Tuesdays is in B, but not in A, so Tuesdays is not included. But here it has Wednesday, here it has Wednesday. So Monday, Wednesdays are the common part. Fridays are in A, but are not in B. So that's why we have Mondays, Wednesdays. The common part will be the intersection. All right? So please review this lecture. I'll see you next time.